Hello, this is day 16 of chapter 12 sequences and series. This is binomial probabilities. So this gets legit. We can use these expansions to solve problems given the probability of success or failure. So let's just say, what's the probability that the next 3 out of 4 days is sunny if the weather app shows an 83% chance of sun this time of year? Okay. So we're just saying, this time of year you have an 83% chance. Well, what's the probability that the next 3 out of 4 days is going to be sunny? Okay. Well, the two opposing things that we have is, our success or failure is sunny or not. So we can just say, S equals sunny, N equals not sunny. Or you could do rainy or whatever. You can choose whatever you want. And we're checking for 4 days. That's the total amount. So this would be like S plus N to the 4th power. And I think I remember the row of 4 for Pascal's triangle, but if not, you can always just recreate it. 3, 3, 1, and the 4th row 1, 4, 6, 4, 1. Okay. So we would have those numbers, the coefficients 1, 4, 6, 4, 1. And here's what would go there for this expanding binomial. And you may get faster at this to not have to do this exactly every single time, but for now, I'll write it out. This would be all 4 days are sunny. There's only one way for that to happen. And there are 4 ways for it to be sunny 3 days. That's a 3. And not sunny 1 day. There are 6 ways for it to be sunny 2 days, not sunny 2 days. Okay, and you can see the pattern here, same pattern. The difference here is that now we actually have a probability of sun. So in any of these days, if it's whatever it may be, you have an 83% chance of sun occurring, of it being sunny. So 3 out of the next 4 days being sunny. So that would mean we need to know which of these terms is going to give us 3 sunny days out of 4. And we could look at this and be like, well, that would be S to the 3rd, N to the 1st then, right? Like 3 sunnies out of 4 total. Okay, so that's this term. And what's the probability? Well, we have the fact that it's 83% chance of sun. So really, we would say this is 4 times S has a 0.83% chance of happening. So 0.83 to the 3rd, 0.17 to the 1st. Okay, and I just got 0.17 because if it's an 83% chance of being sunny, that means it's a 17% chance of it not being sunny. Basically the complement. And we would then need to calculate that. Get 4 times 0.83 to the 3rd, and then times 0.17. And when I did this, I got 0.3888, so 0.39 about. Or that's a 39% chance. And this should make some sense if you think about it. You have an 83% chance, which is, granted, is a pretty decent chance of something happening. And that's for 1 day. So you have 83% chance. And now we're going to try and string out, not necessarily 3 in a row, but at least 3 out of the next 4 days. And exactly 3 out of the next 4 days. So it could be, sunny, sunny, and then not sunny, and then sunny. And that would count. It's not consecutive, but it is 3 out of 4. But you having an 83% chance of sun actually happening one way or another, when you start compounding these events, having these events all be included within one another, your probability goes down. So it seems like a low percentage, but it should be because we are saying we want it to be 3 out of 4 days, and so it's an 83% chance, an 83% chance, an 83% chance, and then a 17% chance. And there is also to take into consideration, there's 4 different ways for that to happen. It could be sunny, 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 and then not sunny, or it could be not sunny, and then sunny, sunny, sunny. So that kind of it's an interesting way that this works out, and it's kind of neat, in my opinion. Okay, so let's say you flip a coin 5 times. How many arrangements are there with exactly 4 heads, and what is the probability? All right, well, a couple things we know. Flip a coin 5 times, that means we're going to have heads and tails, 5th power, and we also know that heads, it has a 50% probability of happening, and so does tails. Okay, we just kind of know that from, I guess, world life experience, flipping a coin. How many arrangements are there with exactly 4 heads? So Pascal's triangle is going to say 1, 5, 10, 10, 5, 1. Oops. We should have that written down somewhere. It's 10, 10, 5, 1. And arrangement with exactly 4 heads. We kind of did this one in the previous lesson. So this would be h to the 5th. This would be h to the 4th t, and we see that there are 5 arrangements anyway. And what is that probability? So I guess that's kind of asking us, what's the probability you get heads exactly 4 times if you flip it 5 times? And it shouldn't be that high. I mean, that's basically like, it's not talking about doing it all in a row, but you are getting, a desired event that has an even probability of getting it in the first place 4 times. So probability then, if we're saying exactly 4 heads, what's the probability? We would take that term 5, and then heads is a 50% chance, raised to the 4th power, and then 50% chance for tails. So all we're doing is plugging in the probabilities, essentially. So it's the only new real step that we're doing. All right. So we have to put that into a calculator. 0.5 raised to the 4th power, and then times another 0.5. And then times 5 up front. We have, I have 0.156, let's say, or a 15.6% chance. And to me, that makes some sense. It shouldn't be a very high probability if you have it's 50-50 to get 1 heads. You should get 1 out of 2, but we're trying to get 4 out of 5. So it's not going to be 50%. It's got to be less, right? And then the problems can get a little bit more tricky. How many arrangements are there with at least 4 tails? And what is that probability? So I'm going to go back up to this. So, you only have to write it once. And I haven't had to write much of this expanded binomial yet anyway. There are at least 4 tails. So let's see. When we get to, this one was H3T2, H2T3, HT4, and this 1 is T to the 5th. At least 4 tails. So that's both of these ones on the right. And what is the probability? So we have 6 different arrangements with at least 4 tails, 5 plus 1. And then what's the probability? Okay, 5.5 times 0.5 to the 4th power, be consistent here, plus 1 to the 0.5 to the 5th power. So I have to add up all of these, or both of those rather. All right, and I was able to do that because I already had, just for the sake of seeing if we can recognize it, I already had this in my calculator from before. And I hope we can recognize that this is the same thing. It's different context. Obviously, we're talking about heads before, and 4 heads and 1 tails, but this is 1 heads and 4 tails because they have the same probability, is the same outcome. And then there's a 5 up front in both of them. So I left that in the calculator, and then I added 1 times 0.5 to the 5th power. And I got 0.1875. So about an 18.75% chance. of getting at least 4 tails, meaning it could be it could be, you know, either four tails or all 5 tails. So we have one extra possibility, and that's why this that's why our probability increased a little bit from this one, even though they should be identical. If it was exactly 4 tails, should have the same probability. Because we say it's at least 4 tails, we get a little bit better chance. And you've noticed that I rounded differently in both of these problems. There's no significance to that. I just this 15.6 had more decimals to it, so I chopped them all off. 18.75 was all of it, so I kept it. Typically, I'll go to the 10th place, but that's neither here nor there. All right, when given chemotherapy to a particular cancer treatment group of 8 people, how many groupings are there of at least 2 that show improvement? So show improvement or not show improvement is what we're looking for. Improvement is I is improvement, and then N would be not showing improvement. And 8 people. Let's check out our triangle. We need to get up to the 8th group. This may take a second. 6, 15, 20, 15, 6, 1. 1, 7. Oh, this is not fun. 21, 35, 21. 35 again, and then 21, 7, and then 1. Yeah, cut off here. And then it would be 1, 8, 28, 56, 70, 56, 28, 8, and 1. Okay, that's our numbers. So 1, 8, 28, 56, 70, then symmetric back down. 56, 28, 8, 1. All right, so this, if we expanded the binomial, 8 people, this would be I or N to the 8th. Those are the coefficients we'd get. How many groupings are there at least 2 that show improvement? Okay, so let's kind of think about this a little bit. I'm going to work backwards. So this would be T, to the, or not T, N rather. Not showing improvement to the 8th. This would be improvement not to the 7th. All right, and then this one would be improvement 2nd not to the 6th. And then this is where we'd start counting. Because this is 2 that showed improvement. So certainly as I keep going up, I'm going to keep getting more and more and more. So this is kind of where it cut off. I include the 28, I include the 56, because that's going to be, I to the 3rd, N to the 5th, and our first term, of course, is I to the 8th. So between all 8 being, all 8 people showing improvement, and 2 people showing improvement, all of those ones in between are all going to be included in having at least 2 that showed improvement. So I don't need to keep on writing here. I know that all of those are going to be included. I'm going to count them all. The only ones I'm not going to count are those 2. So that's going to take me too long to do in my head, so I will use the calculator. 1, 8, 28, 56, 70, 56, 28. Enter. I got 247. So that's how many different groupings there are, arrangements. If the chemo has an 82% rate of improvement, so let's say, this is saying your improvement has an 82% chance of happening. What is the probability that exactly 7 of the group will show improvement? 7 of the group will show improvement. So we need to figure out which term that is. 7 shows improvement. So I'm just start at the beginning. This is first term is I to the 8th. The next term is I to the 7th N. our next term, these are all added together. Our next term would be I to the 6th and squared and so on. And we already found it here. It's how many exactly 7 shows improvement? That's this one. And it says exactly, so I'm only taking that term. This is 8.82 to the 7th. And then your n, it only says 82% chance rate of improvement. Well, that means it's an 18% chance of not improving. So 18% chance right there. All right, so this is 8 times 0.82 to the 7th times 0.18. I get 0.35897. That's a lot. I'd say 0.359 or 35.9% chance. So if you have an 83% chance of improvement, and there's a group of 8 people, what's the probability that 7 of them will show improvement? And it's basically a 36% chance. So this is rather awesome. I kind of really think this is cool that these binomial probabilities are two opposing things. When you plug in the probabilities, you get probability of some certain event happening that wasn't really part of something that we know about. All we know is that you have an 82% chance of improvement. We don't know what your chances are of getting 7 of those to happen. So it's kind of neat. All right. The next few questions is the assignment. So I hope this helps, and good luck.